In 1980, a plan was proposed to run high-voltage transmission cables from the Nanticoke Generating Station, situated on the north shore of Lake Erie, to a terminal site in Pennsylvania. Through the summer of 1980 to the spring of 1982, the Geotechnical Engineering Department of Ontario Hydro carried out offshore investigations in the eastern basin of Lake Erie, along a study corridor 4.5 kilometers wide and stretching 105 kilometers in length. The offshore investigations included diamond drilling from barges, lake sediment sampling, and geophysical surveying. These investigations established the lake bottom and sub-bottom conditions along the proposed corridor. The geophysical surveys, using side-scan sonar and echo-sounding equipment, revealed ice scours in the softer lake bottom sediment. These scours were found on the Canadian and American side of the corridor in water depths ranging from 13 to 25 meters. These scours are up to 6 kilometers long and up to 2 meters deep, and are caused by ice gouging the lake bottom. To better understand the ice conditions on Lake Erie, an ice monitoring program was carried out during the winter periods of 1981 and 1982. A helicopter was used to observe the ice pack and ice ridges. Ice ridges were a common occurrence in the ice pack. The more significant ridges of about 10 meters in height were observed on the Nanticoke Shoal, 5 kilometers offshore the Nanticoke Generating Station, and along the American shores. The grounded ridges on the American side extended for several kilometers parallel to the shoreline at the edge of the fast ice. The fast ice was attached to the shore and extended about 4 to 5 kilometers offshore. Ice ridges ranged in height from less than 1 meter up to 10 meters. The higher ridges were definitely grounded on the lake bottom in water depths of 13 to 25 meters. On February 26, 1982, we were lucky to find a large ice ridge mass in the process of forming. The ice ridging process that can build ice to such heights and depths is of considerable interest. The following scenes have not been edited. The sounds you'll hear are ice cracking and wind blowing, and as a result, no further commentary is necessary.
forming at the present time. The ridge appears to be grounded in possibly 20 meters of water. The ridge is located at approximately 42 degrees, 26 minutes, 59 seconds north, and 80 degrees, 23 minutes, 40 seconds west. The ice thickness is 0.4 to 0.6 meters thick. The ice blocks are being thrust up and down as the ice mash is pushed by a 15 to 20 knot westerly wind. The ice contains considerable soil from the lake bottom. The water is very muddy as a result of turbulence caused by the down-thrusting ice blocks.
The flat ice sheet you are watching is about 60 centimeters thick and is being driven by a 20-knot wind. The ice ridge is forming as the ice bends and breaks and is piled up. The ice sheet is also thrust down beneath the ridge. Lake bottom sediment in the ice is responsible for the dirty ice zones. On March 3, 1982, the same grounded ice ridge was observed again, only this time there was no active ridging in the area observed on February 26th. The Loran C navigational system on board the helicopter enabled us to locate the ice ridge map and return to it at a later date.